that comes up a lot these days is how does robotics interplay with artificial intelligence?
There are other types of robotic
And
mobility.
this is actually an important question to think about because it gets us to what are some of the new frontiers in robotics these days. So let's think about it for a second.
That's not necessarily the only type.
Success stories in robotics, we have plenty in the past. And for example, as I was mentioning, the robotic manipulators, industrial robotic manipulators in assembly, in manufacturing, have had a profound impact on society. Many of the things that we use today, that most of us are lucky enough to be able to use, are as well made as they are and are as affordable as they are because of robotic manipulators. It's not only thanks to robotic manipulators, but manipulators have played an important role, right? So this is one place where robotics has had already a profound impact on society. What's next? What are the new frontiers? And you can probably tell by now, based on how many times this came up when we were looking at all that list of where robots are today, what's possible, that really a big and important new frontier is what we call in the field unstructured environments. So situations where it's no longer possible for a human in advance to tell the robot exactly how it'll need to move. But there will be scenarios that the human programmer cannot foresee. And this is the definition for us of unstructured environment. A structured environment is one that you know exactly what it's like. It'll never change. So if you program one particular robot movement, picking up a part, placing it in a machine, taking it out of the machine, putting it back down, then that exact movement will work again and again and again because that environment will never change as long as the robot has to do the task. Unstructured situations, though, are more difficult. That is one of the important new frontiers in robotics. And how do you handle, as a robot, these unstructured environments? And some abilities become truly critical. Sensing, right? If something will happen in the world that has not been foreseen, in order to react appropriately, you need to be able to sense that. So perception and sensing for robotics become critical as they move into these unstructured environments.
We are back in a way.
And then it's not enough just to get the data about what's happening in the world. You need to be able to react appropriately, right? An unexpected obstacle jumps in front of me. The reaction, I'm going to stop and avoid the collision. But then the next thing that happens is, at a higher level, planning. Okay, so the trajectory that I was executing is no longer viable. An obstacle has jumped in front. I've stopped, right? I haven't hit anything. All is good. But still, how do I continue my task if the trajectory that I had been programmed with is no longer viable? Now the robot has to plan a new trajectory that will allow task completion, right? And when you this idea that sensing, reacting, planning are critical for unstructured environments applies to mobility, it applies to manipulation, and it applies in sometimes surprising fashion. When I talk about sensing, maybe the first thing that comes to mind is cameras. You know, let's put cameras on robots so that they can see the world around and then they can react to it. Of course, that's one very important way of doing it, but there are other senses, right? So here's an example in manipulation, also from KUKA, where a robot is endowed with a different kind of sensing.
And then if you think about it,
so here is what looks like a very traditional robotic manipulator. And this image is meant to show that traditionally humans and robots in manipulation were separate, were always separate, never sharing the same workspace. Why? Because of safety. It wasn't safe for a human to be in a robot's workspace. Well, here this robot is equipped with the ability to sense forces and torques. And in particular, it can sense the torques that it is applying at every joint, and it's able to regulate and control the torques that it is applying at each joint. So now, this robot can be safe to interact with. if it touches you, or if for that matter it touches anything else in the world, it can sense that, and it can regulate and not apply too much force to the world.
Once you stop talking about just bits.
Right? So and then once that happens, then all of a sudden it's safe for a human, it can be safe for a human to be in the robot's workspace. The human can even guide the robot along, which is what this video is showing, right? So again, traditionally, an industrial robotic manipulator like the ones that we've started with, incredibly precise, can be incredibly fast, has no way of measuring or reacting the forces, or reacting to the forces that it's applying to the environment, the torques that it's applying at its own joint, and as such, if something gets in the way, there's potential for a lot of damage to be done. Traditionally, it was not safe for a human and a robot to share a workspace. That's changing now because of new types of sensing, new types of being able to, new types of algorithms for reacting to the sensed data. Here's another example, this time from Rethink Robotics. And here again, they're showing a robot that has the ability to directly physically interact with humans, that a person can just pick up, they can move, they can guide the robot around. The robot is compliant. So the robot is executing the task. It's safe for a human to be in the workspace. It can be safe because then, if an unexpected collision happens, the robot senses that and reacts appropriately. So this is really an example of the new frontier in robotics enabled by sensing, by reacting. So sensing doesn't have to be just cameras and vision. There are many types of sensors, many sensing modalities, and all of them are important for robots to move into unstructured environments, for robots to be able to also physically interact with humans, which is a very important new frontier in robotics as well. Okay, let's look a little bit more now at this idea here, right? The programmer cannot provide exact instructions in advance for every scenario that the robot will see. This is, in a way, the essence of a robot handling unstructured environments. So if you look at the way this is phrased, right, if the programmer cannot tell the robot in advance what to do in every situation, does that mean that we're trusting the robot to be intelligent, to react on its own? And the reason why I've highlighted the word intelligent is that, again, here we are opening another can of worms, right? We've said that it's very hard to define robotics. It's even harder to define intelligence, right? So if you think about artificial intelligence, as far as I know, there's also no universally accepted definition. For intelligence itself, for that matter, right? For artificial intelligence, but also for intelligence in general. How do you define intelligence? There is no universally accepted definition, at least that I know of. The one that I like to use, that I guide myself based on, is I think of intelligence as the ability to react appropriately when faced with unforeseen situations. And of course, this is not a technically crisp definition. What does appropriately mean? What does unforeseen mean? But again, the purpose here is not to give a technical definition, but just a sense of how to look at things. And what I like about this definition, right, is that it can apply to humans, it can apply to robots as well. It can apply to intelligence, it can apply to artificial intelligence as well, right? Think about how you are giving directions to a person to do something. Maybe you're sending a child to pick up something from the store, right? And at the beginning, you give them very clear instructions. Once they're old enough, you say, you need to go 2 blocks, then make a left, right? Then you wait for the light, then you cross the street. Maybe, let's say they need to take the subway. You say, here's the subway card. I've made sure it's charged. You swipe, you take the subway. So you try to give them in advance instructions for everything that they might encounter along the way, right? Then, as the child grows, right, and if the subway doesn't work, then you cross the street, you take the bus, you don't ever get into a taxi, let's say, just as an example, right? As the child grows, you stop feeling the need to give them exact instructions in advance for anything that might go wrong, you start trusting them that they will know what to do if something is different. If neither the subway works nor the bus, they'll know what to do. They'll know how to maybe pick up the phone and call you, or they'll know how to walk maybe, and it's a longer time, but they'll still get to where they need to go. So you start trusting them to be intelligent, right? And really, it's the same with robots. It's the difference between programming a robot with exactly the way it needs to react in any contingency. Think of it as a whole bunch of if statements. If this is the case, then move like this. If that is the case, then move like that. At some point, the world becomes too complicated for if statements. The list of if statements just grows too large, right? So once you can no longer tell the human or the robot, if this happens, do this. If this happens, do that. You need to start trusting them that they will react appropriately. So true in robotics, true when thinking about human intelligence, right? And for that, for the ability to react appropriately when something in the world is different and you cannot possibly give them instructions for every contingency, then sensing and planning become key, and this is where a lot of the work in robotics and in artificial intelligence is coming together.